Recorded. I guess I should start off. Rob, got anything you want to say, or should I just start going?
Well, let's see. I'll just say this. I don't know what you got planned exactly here, but I'm happy to be involved however I can be. You know, everyone who knows Martin knows that he tinkers in the shop a lot. A lot of reasons for that, but
I'm
it's
divorced now, so
so it's been fun to learn from him a lot over the years. I guess we go back about 15 years, and I've been teaching the Foundry for about 10. So yeah, I'm just glad that he hasn't completely retired. He's still filling in, and we get to work together in a little bit role reversal kind of mode. But it's been really cool. So yeah, let's see what you got.
it's been liberating. And Rob's a much better teacher than I am. I'm a politician. I'm not a teacher, and Rob really pays a lot of attention to that. He's taken over my role both statewide and nationally with the foundry industry and the metal industries, and I just couldn't be happier. And and he's dumb enough to do things like this conference where he doesn't make any money for doing it. So, that's the way we go. But one of my fundamental beliefs is that the more you give, the more you get, and I'm a greedy bastard, so that's why I do this kind of stuff. But let me share my screen and we'll get started. Let's see. So do you see that?
Yes.
Okay, I'm just going to go through the odds and sods. One thing I'm a great fan of, even though I haven't convinced our machining guys too much to do that, is the utilization of machinable wax. Those of you who know me and been in the lab have seen the stuff we do. It's relatively inexpensive as the wax can be reused. It's easy to mold into different billet shapes for your projects. Allows very high speeds and throughputs, and we'll talk about that in a minute. Has almost no cutter wear. And there are different types of machinable wax. And, whoops, put the cursor on the right one. And so first of all, for just some machining, you can use it for what we call proof of tape. That comes from the old NC punch tape, but the proof of your program and your tool paths. So, when you're teaching different, roughing out or whatever tool path in Mastercam or Fusion you're using, you want to see what the effect of the step overs are on the surface finish and that sort of thing. There's no reason to machine aluminum and put that up there or whatever it is when you can throw up a wax, quickly go through it. It's very efficient on that. Oops, my camera just kicked out because why would my Microsoft camera work with the Microsoft operating system? That's just too much to ask. But you can machine a lot faster in the machinable wax. And so when we're doing that, for example, I think it was last year, I had one of the machining students in, and we're machining, and he's used to working at aluminum at 6 inches per minute, and I crank it up to 200 inches per minute, and he's go, whoa, what are you doing? I go, yeah, I know, we should really go to 400. But your throughput is incredible on that. And so instead of having a student on there for an hour, you might have them on there for 5 minutes, and it'd be really good to optimize your stuff. Once again, just as you're doing your tool paths, did you get in and rough out that corner? Are you cutting the right program? I remember years ago, I had a graduate student from Arrow. He's going to cut a piece of metal to be a base plate in the shaker table lab. And I said, why don't you do it in foam first? Cut out a block of foam. He goes, no, blah, blah, blah. And so he cut the same geometry, the top geometry on both the top of the plate and on the bottom of the plate. And so then he had to order another plate out of Los Angeles for $400 and all of that. And it's a good thing he saved 20 minutes by not machining the foam as a proof of tape, because he could then waste a couple of weeks of money doing that. So it's much more efficient, much higher speeds, much throughput, and has almost no cutter wear. And so I make it as one of my rules. I try to change out my tools every couple of years. And we use a 16th inch ball end mill from Harvey Tool. And so we're cutting, let's say, 1,000 patterns out with that tool. And it's not dull after 2 years, but just as a change up, we change it out every couple of years. So it's incredibly cheap to run these things in the wax. And so here are a few examples of the stuff we've done in the past. I used to have the mini mill. I now just have the compact or office mills. I give the mini mill to Trian and he gave it away. But so I was playing with the 4th axis. And so here you see that I've cast my machinable wax around a Delrin rod that I then put in the rotary device with an end stock on it. And so you can see just how you're mapping it around. So you can do some interesting things with that. This is another example of strange utilization of the machinable wax. They were making a frame for a human-powered helicopter that Koch in a facility was. And so they wanted to do the layup of the carbon fiber and make a carbon fiber C-hook type frame for it. And so I suggested that they make these wax patterns. We cast them with a hollow hole in the middle using complicated things like 3/4 inch pipe. And then they machined it out, and you can see the indexing method that they have on the left picture. So they could stack them up and then curve them out. And then they lay up the carbon fiber around that. And then the carbon fiber, there's different regimes, types of fiber, regimes of protocols and heating you go through. And so one of them is, the first set is at room temperature, and then you do an elevated 200, 300 degree Fahrenheit bake of it. And doing that, it melts out the wax. So you can lay up on these pieces that you assemble together and then do the carbon, and then melt them out and have your carbon fiber pieces. Normally in industry, you'd use some kind of plaster to do that. Another example is when I taught the machining lab, once again, just showing, God, this camera keeps going in and out, just showing the tool paths. If you look on the right there, you'll see I made a cross section, or cut a section about 1 inch tall out of the extruded aluminum framing stuff. And then I cast my wax into that. When you're machining the wax, you have to be able to grab the wax. And you can't just throw it in a vise. And that's what we do. I'll talk about that later. But you put it in a vise, it'll cold form on you. And so it's good to cast it around something if you can. And then so I can grab that metal in the vise. And I wish I had a little, let's see if my camera works and I can show you this live. My camera's been kicking out because it knows that I might need it. All right, so you can see I can cast the Z on the piece tall. So we can come in and cut out one student's geometry. After that's done, we can drop the Z down, face it, cut out the next set. And so I might cast this as 8 inches tall, or whatever can fit in my mill. And then I can end up with, 8 or 6, whatever, different billet uses out of this one piece. And then when I get to the bottom, I can just melt out the wax and then reframe it and pour another one. So it's quick and fast and easy and cheap and easy to work with. So once again, if you're showing just tool paths, why do you have to cut out of metal to see that geometry there on the left and see if that's what you wanted and see if your tool actually can reach into the, if your tool holder, you call it or whatever, slams into the top of the wax, nobody dies. So it's not a tragedy. So let me go back over to our next one. And this was an example of what we call the ergo knife. This is for our QL Plus, which is an organization here at school that tries to help disabled war vets and military, police, etc. And this was a knife that was assigned from somebody from Veterans Hospital for how do you hold a knife to cut your meat or whatever when you don't have a thumb. And so I don't have a picture of it, but this is meant to go in between your 2 fingers on the left and 2 fingers on the right. And so to prototype this, before we went hard tooling for plastic, we machined out the wax that you see on the top left there and machined it with some guide holes and stuff, and then poured our RTV silicone in there and came up with a, you see the lower left, we machined a left and a right version of this cavity on the top left. On the bottom right, bottom left, you'll see the 2 mold halves. and just index together with regular pins, and then use that, put the knife in there, and then cast the plastic around it. He came up with a very functional, using smooth-on products, of course, very functional prototype, but very easily done. And so, and you can get phenomenal surface finishes if you use coolant when you're machining that. Going on, Bill talked about going to Kenya, and this was a project, Lunar Light, for solving a problem of lighting in the huts in the villages in Kenya where there's no electricity. And so what they had was solar power would charge a light, and so use that light at night. And so we wanted to have the plastic cases for the prototypes of these, of those. And so once again, we machined out in the wax and did silicon rubber takeoff, and ended up with systems where we could pour our plastics into and then get the plastic housing that they could populate with the circuit boards and the lights and the lenses and those type of things. So machinable wax is not just for proof of tape. It's actually, like I say, you can see easily that's made for, can be used for plastic, prototyping plastics, etc. So in our foundry uses, we can use it for a number of things. One is making permanent molds, and this is something Rob and I just started winter quarter, which is pretty cool, because we had to, well, I'll get into that. So permanent molds out of brass, you machine the master wax pattern, do a rubber take off of that, sand mold, cast permanent molds, and then cast aluminum into the brass permanent molds. You don't have to have steel to cast aluminum in as permanent molds. And then a second project in the class is our CP keychain tooling, and we're going to make hard tooling. There'll be plastic tooling, and so we'll see that we want to machine a wax master, rubber plaster, plastic tooling, and then use that for sand. And then we have our infamous medallion project that most of you have probably seen some about, and we'll go over that in a minute. So continuing on, here's our permanent molds. And so what we do here is, let's see, do I have that on my next slide? No, let me go back. I meant to put this in. Oh, good, I'm still live. So, oh yeah, no, we got it here. So I had this horse head geometry on the plate, and you see the horse head down below, and the horse heads look like this when they come out of the dies. And we use this as our first casting experience, just so the students can get a sense of how to pour from the ladle, et cetera. Oh, okay, that works. So I'll show you those in a minute, a little more detail. We made two types, candy bar mold, basically, and then the horse head molds. And what we started off was using the photogrammetry, the used to be 123D Catch. I forget the name, it'll come to it. But what you're looking at here is a surface that came from taking pictures with my camera, uploading those pictures into Autodesk, and then it came back with a surface. And then from that surface, I went in and machined out. First of all, I scaled it, because once again, it's in CAD now, I can do all that. And then I created what you see here. So on the top left is the machined out wax, and then the rubber takeoff. And now that rubber takeoff is the shape that we want for our permanent mold. And so we just sand molded against that, and then cast what you see on the right. I got a little more polishing to do, but this rough area, that doesn't affect. That's not in the casting zone. So a little more work to do. Lower left, you see 5 of the molds there, 5 of the castings we do, and then 5 at the bottom of the, after it's been cast, and what we have down here on the left. And so here's just a horse setting on the mold, and we get those parts. And so we don't have to mold in sand to get these. So we can make hundreds of these. Say you had your school mascot, emblem or something. Or what I'm particularly interested in is if we were doing this event at our place, well, for example, in 2015, we hosted the H-Tech National. We made 450 or so castings, and we made the sand molds for that. So we made 900 pieces of sand, et cetera. if we could quickly in a day, which is what I could do, make a set of permanent molds, then our only constraint is our melt rate in our furnace, not the molding of the sand, etc. So once again, very simple and easy to do. And so here you see us machining out the pattern. And the billet actually I make from the round stock, we'll see that. I make it from the inside of a PVC plastic clean out hub. So in the top right, you see the machined wax, etc. Then the rubber takeoff. And down below on the left, you see the plastic with the smooth on quick cast, and then the sand mold, and then the resulting keychains. When we make these keychains, every student makes a mold set and pours and gets 6 keychains. And so sometimes we'll have 200 students in the class, so we'll make 1,200 of these that week. And so amazing output, amazing output. And then we have our medallion project. On the top left there, you see the fancy system we use for melting the wax. It's called a turkey baster from Target for 30 bucks. In the middle, you see the clean out hubs for a 4-inch clean out. Not the ABS, that doesn't work because it loses its surface, but the plastic and the $2.99 from Ace. Now it's a plastic injection piece, so it has draft angles on it, etc., and fillets and radiuses and stuff. And so you can see in the top right how we pour those in. So when I'm making these billets, you'll see in the lower left we make these bins, and we'll usually start a quarter with 400 or 500 of these already made, and we can lay out. Going back to the top center, lay out 24 of these, and then just ladle the wax into them, and then let them set. And then I put them in a freezer, and then in the frozen state, the wax shrinks really nicely away from the plastic, and they just pop out. And so we can make 25 billets constrained by our melt of the wax capability in a couple hours. So in a day we can make 100 billets. And if so a student can grab one, machine it. I can tell a student, they'll go, will this geometry work? And I go, I don't know, try it. And so I'm not paying 10 bucks a piece in aluminum to have a billet up there. And everything nice about using these clean out hubs, and they come in 4-inch, 6-inch, 12-inch, 10-inch, is that they have this tab that comes on the bottom. And if you look at the medallions there we're making, they're a one-sided casting. And so we grab that tab at the bottom, and I'll show you that when we do the simulation in the Mastercam. And it makes it real simple to make. And so every student makes their own. Wax sources. I'm going faster than I thought I would. There's different types of waxes out there. Now, most machinable wax that you'll be familiar with, it's typically blue. It's more plastic in it, and it melts at about 250. We use a wax that's designed for investment casting. It melts at 150 instead of 250, which is a lot easier to work with. It shrinks a lot less than your blue wax at the 250. You get horrendous shrinks with that. And one thing with casting the wax into your billet shapes is that you want to be where the wax is as cool as possible when you pour it, because the shrink just goes up incredibly with the heat. But using the Master Proto wax from the Freeman as opposed to the machinable wax. So if you look at the screenshot I got below under Freeman Supply, and there's machinable media. And if you click on that, that'll take you to the different wren shape and different waxes. You have to look for this Master Proto wax stock. It's down through the, I think it's Foundry Tools and Supply link. So it's in there. It's a machinable wax, but it's not listed under the machinable media in there. So it's a different type of wax, investment wax. Every investment foundry I know has used the machinable blue wax and for investment casting with a ceramic shell. But the problem, it melts at 250. And so when they go in there and they put it in the autoclave, it expands and cracks the shells, and they go, this doesn't work, while they're using the wrong wax. If you use a wax that's formulated for investment casting, then it's a whole different story. And so now I'm going to do a demo on the Mastercam, and let's see if this comes up. Do you see that?
Yes.
Okay. So we have a 1 unit, 3 hour a week, 10-week freshman level course, and no prerequisites. And so how do we go in there and train them or enable them to make their own pattern without teaching them CAD and without teaching them Mastercam? And so we use Mastercam, and we use Mastercam Art, which is a plugin for Mastercam. And we come up with a template, and you'll see the toolpaths there on the left. So we bring in a template that they then will come in and modify. And so I'm going to come in here and simulate this or verify it. And so here we go. And I've got stop conditions set up, I believe, here. And so we put this wax, and this stock does not show that stub that we have that you saw in the real wax version. So we can set that in our vise, and we don't have to come in there and probe it or anything. We just have to have it, I align it with my finger when we put it in there. Because the first thing we're going to do, when you pour the waxes, there's no control on the Z. You'll see the shrink face on the top. So first thing we're going to do is we use 3 tools: 3/8 flat end mill, a chamfer bit, 45 chamfer, and then a 1/16 ball end mill. So first thing we do is we come in and we face it. And so depending on how thick your stock is when it's going to start to cut. Now we're set up and we've got a unified Z. We're good. But we're not sure that we're aligned on the XY to our G54 value. So the next operation, once again with 3/8 flat end mill, is to contour it. And because this casting is going to be a one-sided casting, we don't care if that tab below is not centered on the centering of our geometry at the top. So now we know that this stock now has been faced to the right Z, and it's been contoured to the right G54. And then we come in and put the chamfer on it because you have to be able to pull it out. And then we use an art function. And this art machining function it's basically a surfacing function. And it's going to take this 16th-inch ball end mill, starting at the 3 o'clock position, do a circle, step in, do a circle, step in, do a circle, etc. So it machines it down. And I did a lot of tests on the step overs. I originally had I tested 5% step over of tool diameter, 7.5, 10, 15. And so at 5% step over, it took 45 minutes to machine out the surface. At 15% step over, it took 15 minutes. So at 15 minutes with 2 mills, we can do the 24 we need for a class in a 3-hour lab. So very efficient, very fast. But then what we do is that machined geometry, it's a flat geometry, not real exciting. So we then come in and we'll look at this from the top. And if you're not familiar with Mastercam art, I'm going to cost you more. We're going to come in here and I'm just going to, let's see. Put in some letters. Create letters. Okay. And they always change the interface. So I'm just going to put in CITEA. And I won't get too fancy with it. Let's see where we are over here. I'm going to put this in as arc, like arc-aligned text, and I'll have it on the top. And it's going to ask me for a font. And once again, you can't use a stick font because, you know, you just can't. So I have to come in and choose a font. And Okay, we'll go with that. And then I'll take a size, and we give them all the numbers and they can adjust it. All right. And just for the expediency, I'm not going to, I'll change the radius here to 1.125. Okay, I'm happy with that for our purposes there. Oh, sorry. I'll go back and do that again. Should repopulate. All right. And then I can, so now I can come into art, organic, and where's area? Is that area? Area. And I choose a section to be raised. And it's going to go and raise this area by what I tell it to raise it. And I give it a radius. And this is pretty cool because if you ever tried to extrude stuff and you want to put a draft angle on it and all of that, you can really run into problems, especially at the point of where the A triangles come in and that sort of thing. So now it's taking this geometry that it's not really geometry, it's more construction lines. But now it's going to modify this art-based surface, which is what the grid pattern in the background is. And we machined that and it came out flat. Now, if you look at the lower left, we have our 4 tool paths, the facing, the contour, the chamfer, and then we have the 16th inch ball end. It really gives us our geometry. And so what we see here now is that that tool path has now become dirty because we have modified the surface from which that original tool path was derived. And so we can bring in pictures and do things here. I won't go through that just because we don't have time. And like I say, there were 2 things that allowed me to be able to develop this, which I did a number of years ago now. One was that the Raiders sucked and I didn't have to be bothered by watching them score or make touchdowns while I was doing this. And the other was this, the regeneration of dirty tool paths. So in the template, it was tool pathed off that flat art-based surface. We modified that surface. And now it's regenerating the tool path. And this is super cool. Okay, so now you see that toolpath is clean. So I'm going to select all of them, go back into verify. Rotate this back a little bit. First operation was face. Second operation was the contour. So now we're aligned to G54. Third was the chamfer that we needed to get these out. And then we do the ball end mill. And I'm going to turn off the representation of the wireframe. And so I can zoom in and I can see cutter marks, but you know, as you know with CAD, you can see a lot of detail you can't see with your eye. So this is really real happy with that. And so at that point, the student has now modified, they put in a picture, maybe just a CP or a horse representation, whatever. And then from here, we can post this code, take it over to the mill, machine out that part in the 15 minutes, assuming our metal's ready and our sand's ready. So we can go from this part to having a casting, not all 24 at once, but we can go from this point to having a casting in 30 minutes or less. So we can go from art to metal in 30 minutes. And it's great. It's easy to work with. Very nice with that. So I see I've still got live on here. Does anybody have any questions? I know I've gone a little faster than I thought I was going to go.
Real quick, great job, Martin. This is Frank. They are including art now as part of the program for Mastercam as of 2021. So
Oh,
for anybody that's going to be up, it is a release 2021, maybe just a couple of days ago, but from now on, it's going to be built into the main program.
and will it be included in the home edition?
I believe so. Yep.
Oh, that's great.
Yeah.
That's great.
I'll confirm that, but I think that's what their plan was. It may not be there yet, but that's the plan.
Excellent, because the problem we're facing in the lab is, you've seen our lab, it's just computer lab's a long, skinny one, and we can maybe only get 4 people instead of 24 in there.
Right. So that's the idea. I'll have more information on the HLE version if it's going to have it or not, but usually they'll do a little bit after the main version gets released. So that's good. That happened just like last week, 2021.
Yeah, we haven't upgraded to, as you know, this year's version. We don't know if we're going into the lab, and so,
right.
Who knows? I really don't know I doubt I doubt that we're going to be in the lab this fall. We're planning on it. The school thinks it's going to do it. But
this would be a good project, I think, if they're doing distance learning, that you could walk them through if you have the HLE version of the art and make it.
That's exactly right. That's exactly right.
Right.
And have I driven everybody away? How many people we still got? Oh, we got more than enough. Once again, if you came in late, using the machinable wax, using the clean out hubs to cast your billets in there. You can check out your tool paths, make sure that you went and actually got the geometry that you wanted. It's pretty cheap, and I know you high school people have nothing in the way of budgets. So the wax is about $5 a pound, but you just pick up the chips. I use a special vacuum just for the chips.
Can you show your screen, Martin? Right now we're looking at your email, I think, or something.
Oh, yeah, I pretty much got nothing else to put up there,
okay.
but
Okay.
We can go back to,
Yeah, all right.
Something like that.
Oh, great job. Great presentation. Did a great job on Mastercam.
Yeah, we're looking at Fusion because of the at-home thing. And so what you're saying, the home learning edition and Mastercam might be a saving grace with that.
Yeah.
But we really don't know. And like I said, our county is now back on the watch list, and we were down to 5 new cases a day, and now we're back up to 60 to 90 a day. And so I don't see us having classes this fall. But if we do, we can't really use the computer lab, so we'll see how it goes.
I'll get that answer for you today or tomorrow, Martin.
Okay.
You can just disseminate it to everybody.
Sure. That'd be good. Anybody else out there? I'm going to stop sharing my screen and so I can see who's out there. Oh, Victor. Hi, Vic. How you do? And so,
now, Martin, my internet went down in the middle of your presentation. Where do you get the wax?
Okay. Now, hopefully all these presentations will be made available to you. But let me go back over the waxes for this. Where was that? There's different types of machinable waxes. And so let me see. Oh, I got it all the way at the end. Here. It's freemansupply.com is where I get it. And when you go to that, can you see my screen? Oh, wait, I need to share that. I think Zoom needs to work on their sharing. Okay, can you see that?
Yes.
Okay, so this Freeman Supply, and you come on there and it says Machinable Media. You click on that, it'll take you down to different woods, and wren shape is a urethane machining media, and then they'll have machinable waxes. And that's not where you need to go. You need to look for this master proto wax, and I think that's under the Foundry Tooling and Supplies, because this wax is, as I mentioned earlier, but you missed it, designed for investment casting. So it's at 150-degree melt instead of 250. It's a little softer, and like I say, melting at 150 is a lot easier than melting at 250. You use that blue wax that you see at the trade shows for the machining and all that. It shrinks horrendously when you're making your billets and different things with that. So you want to go to an investment castable, melt about 150. And there's some other waxes that they have. Rob and I got some samples, but then COVID hit and we were going to test them, but then COVID hit. And so we haven't been doing that. So that's where we're going to go. And then I'm going to show you what I'm doing in my old age. I put a foundry in at home, and I'm casting things like, that's a barrel. Can you see that? Maybe I make this.
Stop sharing your screen.
Oh, that's one thing I don't like about this. And then how do I make me big? I already know how to get big. How do I make my picture big?
Users can do that with speaker view.
Okay, make it speaker view. So you see, this is what I call lost plant casting. It's a barrel cactus, and I've investment cast it. And so every little spline comes out on it, and different type. I put a foundry in at home. Oddly enough, I bought a gas furnace from Lithuania. And they shipped me a steel box full of refractory concrete, cement. It went from Lithuania to Hungary to Poland to Paris to Dallas to here. And it was within 2 weeks. It's just amazing. Yeah, I now cast at home. So we're setting up a little business doing lost plant castings and stuff. So if you have a foundry in your facility and you want to see some of the innovative, cheap ideas we do, contact Rob and I, and I'm at mkoch. Cal Poly EDU, and Rob's at RV Carter. And we'll be happy to give you some of the insights we have, because we're pretty good at doing it. Very cheap, very small space, and nice setup. Okay, how about anybody else out there have any questions?
I have a question.
Sure.
I inherited an old metal shop, high school metal shop, which has a foundry in it.
Oh, we'd be happy to help you.
Is there any documentation on how to start it up safely and stuff?
Not documentation, but knowledge. Where are you located?
I'm in San Jose, California.
Okay. Might even be able to come up and help you out. We can definitely get you some aluminum alloy to cast.
Okay.
I'd probably ask you to go in the lab and we'll do a Zoom, and you can show us what facilities you have, and we can talk about that. You're probably running a Petrobond, so your sand might look a little red. Petrobond.
Yeah, we got two different things of sand outside. They're different boxes.
So one is probably red.
Yeah, I think one's red.
And then that comes from it's oil based. And that's a typical one they use in the high schools, because you didn't have to mull it every time and mix your water into it. So you could mix your oils into it. And you can even buy it pre-mixed. And your other is probably green sand. And
okay.
What Rob and I use, we do some petro-based, we have some green sand, but we basically use a sodium silicate sand system that's activated with a CO2 gas. And I'd be happy to show you that and go on. Like I say, we'll Zoom each other individually, and I'd be happy to show you some things.
That'd be nice.
So doing that. But we can make it so it's quick and small and easy, and help you out a lot with that.
Well, that'd be very nice, because I'd like to use it.
But
I didn't want to power it up and have the place burn down.
Yeah, you probably
Good
got one of
start.
the old small gas swirl furnaces, but we'll have to take a look at your controllers and that sort of stuff with that.
All right.
Another good
Thank you.
source for casting expertise is Victor Oquizan from Cal Poly Pomona. And so he's more on the investment casting side and some of the high-end stuff with that. But,
Yeah, if we can be of any help, just let us know. At this point, probably the easiest thing is to go through Martin, but there's
Okay.
other things also for everybody who's witnessing this. Oh, by the way, Martin, how come you're all red? I just had to ask.
I'm always red. I don't know.
Have you already started drinking? It's just
No.
kind of early in the day. Hey, no, but for everybody else in the call, if you have a Foundry, if you want to set one up, we can help you with that over in the Southern California IFS chapter. We've been trying to actively help with that. And we also have there's different ways in which you can get there, but we can also, we also have an annual casting contest that we would like you to participate in. I mean, your students, but we can get you all that information. At this point, the easy way is to go through Martin and Rob, and then after that, we'll get a hold of everybody who's interested.
All right.
I second that. Victor's been really helpful. I've come down. He's spent half a day doing demos, all kinds of things on simulation and things like that. Victor's been a tremendous help, and we're really grateful for that.
Well, good stuff, you guys. Thank you very much.
You're welcome very much.
Good job, Martin. Thanks. Martin and Rob, thank you.